friends, today I am going to share a most important result related to complex analysis. So this result is very useful for UGC NET India, IIT JAM, GATE. So here is the proof of this result. And first of all, the result is FBA analytic function on an open set U and Z0 belongs to U, F dash Z0 is a non-zero. Then we have to show that the answer of this integral over C is 2 pi iota over f dash z0, where C is a small circle centered at z0. Then how can we prove this result? So first of all, when we take z arbitrary close to z0, then what happens? As at the point z0 function is analytic, then if z is arbitrarily close to z0, then function is analytic also on z. Therefore function is analytic at the both points z and z0. Now what happens with this condition? So we can expand Taylor series of fz and fz0 like this. So we can expand the value of fz like this: a0, a1z, a2z. After that we can put the value of z0 in the fz. We get a1 z0, a2 z0 square, and after that we can subtract these two series. Then we get a0 cancel with a0 and we get the result, and that is a1 z0, a2 z minus z0 square. So we have the value fz minus fz0 in the series, in terms of series. So this is the value that we have to use in the integral fz minus fz0. So we calculate this. Now what is the derivative of this series at z0? So if we take derivative, then we get f dash z0 is equal to a1. So it is given that f dash z0 is non-zero, therefore a1 is non-zero. So this is the equation of this result that we have to use in our proof. So as a1 is a non-zero, also z not equal to z0, z minus z0 is not equal to 0. Therefore product of a1 and z minus z0 is also non-zero. Therefore its reciprocal, that is 1 over a1 z minus z0, is well defined and non-zero. Now we have to find the answer of this integral. So what is the answer? By Cauchy residue theorem, the answer of this integral is 2 pi iota residue at z0. So how can we calculate the residues? So limit z approaches to z0, we have to product with z minus z0 this factor to calculate the residue at z0 with the function of which we calculate the residue, and we can put this value here, value of this function. We will put this value here from this equation. Now we can calculate this limit, and this becomes 1 over a1. Value of a1 is given that f dash z0. We have calculated that. So answer of this residue is 1 over f dash z0. Then put this value here. So we have